Zoom.
Good morning, everyone, and welcome to the lecture. This is lecture number 15, and we are dealing with motion in a vertical circle. What we discussed in the last class, I think we were discussing the circular motion in a horizontal circle, and we had seen how do we make equations of horizontal circle and how uh, vehicles turn on a circular road. They can turn by using friction only. Do we remember this? And we had found out the maximum velocity, root over mu gr, or they can turn using the concept of banking, where this road is banked, and we had seen the different aspects of it. We had also seen the conical pendulum. These are the three or four different cases of motion in a horizontal path. If you can remember those two cases, that are good enough to solve any problem that comes. Now, from moving on to the next type of motion, it will be up till now, motion was happening on a horizontal circle, horizontal plane. Now, the motion is going to happen on a vertical plane. So that is the heading that we are going to write, motion in vertical circle. Motion of a body in a vertical circle. Now, what do you mean by a vertical circle? Now, the motion will happen in a vertical plane, and gravity always acts downwards. In the previous cases, gravity was literally doing nothing because it was just equal to normal reaction from here or there. But now, gravity is going to play another role here. Motion in a vertical circle. What is a vertical circle? Now, if I have to see a motion in a vertical circle, first of all, I need to draw a circle which is vertical. So here is a circle which is vertical. Now, this circle has a center and this circle has a radius. Now, the simplest example of motion in a vertical circle, and we can do it case by case. Case number A, this is motion of a bob attached to a string. That is the simplest example of motion in a vertical circle, bob attached to a string. You can also call it pendulum, but this is actually not a simple pendulum because it is going to move completely. So I just cannot call it simple pendulum. Now, how does this motion go about? If I just take the example, so we will have one string of, let us say, length L, and you will have a bob of mass M attached to it. Now, how will this move in a circular path? Let us call these some points A, B, C, D. These are some important points that I have marked. And what do you do here? You give the bob a velocity, let us call it as VA. You give the bob a velocity VA. Now, what type of motion, or up till what point will it go, or will it be able to reach the highest point or not, will depend a lot on this velocity that I have given it at the lowest point. Now, if I go to the lowest point and if I draw the free body diagram here, what are the forces acting on the bob? Can anyone tell me? At the lowest point, any point for that matter, what are the forces acting on it? It's not a difficult question, it's a simple one. What are the forces acting on it?
Gravitational force, normal force, frictional force.
Take a deep breath. This is a body attached to a string hanging like this. What are the forces acting on the body? Think again.
Tensional force.
Yes, beta?
Tensional force.
Okay, thank God. We remember tension. Tension. Let me call this as tension at point A. So, tension of the string will be trying to pull the block. So, tension at point A, TA. Okay. What? Anything else? Any other force apart from tension?
Gravitational force.
Gravitational force. So, mg. It will be acting downwards. Now, at point A, this is point A, this is point A, this is point A. If I write the equation at point A, how does the equation look like? What equation am I talking about? We have made equations.
Is equals to mg.
We have made equations many times, 10, 15 times we have made the equation. Can you tell me what is the equation at point A? At point A, what will be the equation?
T is equals to mg.
Take a deep breath, and open your eyes. And remember, we are doing circular motion. This is moving in a circular motion. This is moving with a circular path. Go back and please see how we make equations for circular motion. Please see. And then tell me. For circular motion, circular path. We have done it so many times. Can anyone remember? Does anyone remember? No one remembers. Okay. So it is moving in a circular path. The first equation that I make is towards the center of the circle. And I find out what is the force acting towards the center of the circle. TA is acting towards the center. Mg is acting in the opposite direction. So the first equation that I will get will be TA minus Mg will be equal to mVA square by L, the centripetal force. That is the first equation that I make towards the center of the circle. That is the first equation that I make. First equation I make is towards the center of the circle. What is the second equation that I make? Anyone remembers it?
Tangent.
Tangent. So in the tangential direction, would be like this. Do you see any force acting in the tangential direction? This is the tangential direction. Do you see
No, sir.
any force acting in the tangential direction?
No.
No. So there is no tangential force. So I can write tangential force is 0. That implies tangential acceleration at this point is 0. The third equation is in a plane which is perpendicular to it. It is in a vertical plane. So this will be the side which is perpendicular to it. Do you see any force acting on in this direction?
No.
No, so I don't have to write that equation. I will let go that equation. This is my equation at point A. The only equation which is of any use at point A is this equation. And I hope we understand how we have made this particular equation. TA, tension at point A, minus mg is equal to mv square by L. Let us now move on to the next point, and the next point is point B. Point B. And let us assume that the velocity here, will it be same or will it be different from point A? At point B, if you talk about the speed or the velocity, will it be same or will it be different? Same or different?
Difference.
Different, because forces are acting on it. It would be different. Let me call it as VB. Can anyone tell me now what are the forces acting on the bob at point B? What are the forces acting on point B?
Tension force.
Tension. Okay, so I draw this tension force in green. Tension. Let me call it tension at point B.
Gravitational force.
And gravitational force, let me call it as mg. Now please look at point B. So we are here, we are talking about the point B. Now please look at point B. These are the things at point B. What is the equation that you are going to make at point B? Can anyone tell me what is the equation at point B? Can anyone make the equation at point B? Can anyone make the equation at point B? No one can make it. Okay. So the only force which is acting in the towards the center is tension at point B. So tension at point B will be equal to mvb square by L. This becomes the equation in the direction of center, which is going to give us the centripetal force. Tension is equal to mvb square by L. That is the first equation that is made in the centripetal direction. What is the equation that you can make in the tangential direction? This is the tangential direction. This line is the tangential direction. Green line. Do you see any force acting on this green line? No one sees that. The weight mg is acting on this green line in the downward direction. Velocity is in the upward direction, and the weight mg is acting in the downward direction. I can always call the direction of velocity as positive. So if I call the direction of velocity as positive, the tangential force acting on it will be minus mg. I'm taking the direction of velocity as positive. So tangential force becomes minus mg, and that will be equal to mass into tangential acceleration. From here, you will get the value of tangential acceleration, and the tangential acceleration would be minus g. This is the second equation that you can make at point B. So at point B, you have tangential acceleration also, which is equal to minus g. That finishes my equation at point B. Now I move to the next point, and the next point is point C. I reach the point C, and the block is here. The length is L. Let me call the velocity at point C as Vc. Can anyone tell me what is the forces acting at point C?
Tension force,
Okay. On it,
gravitational force,
any other force? Okay.
normal force,
Yes. Tension, gravitation, and another force. Okay. So we have tension TA, TC, downward because it is always string is trying to pull, and then you have the weight mg, which is now also going in the tangential direction. I have okay, tension at point C and mg. Then I color it with blue. What will be the equation at point C? Can anyone make the equation at point C? No one can make it. Okay. So now I look at the direction towards the center. The force acting towards the center is at point C, tension at point C plus mg. Both the forces are towards the center. That will be equal to m into Vc square by L. So this is the equation that I get at the point C. Then I look at the tangential direction. This is the tangential direction here. Do we see any force at tangential direction? Is there any force in the tangential direction?
no sir,
No, that means the tangential acceleration this means the tangential acceleration is 0. That implies tangential force is 0. That implies tangential acceleration is also 0. So that is the equation that I get at point C. So the last point would be point B, point D. How do I make equations at point D? So let me go to point D. The velocity at point D is Vd. Can anyone tell me what are the forces acting on it?
Gravitational force, tension force, sir.
Gravitational force is acting in the same direction mg, as you can see, and tension is acting in this direction. Let me call it as Td. Now, looking at all these forces, can anyone tell me at point D, what is the equation that you can make at point D? Let me write it here because I don't have space. Yes, can anyone make the equation at point D?
TD is equal to MVD square by L, sir.
Tension at point D is equal to mvd square by L. That is the first equation that I have made in the direction of the center. Then I can make one more equation in the tangential direction. If you look closely enough, this is the tangent and this is the tangential direction. Can anyone tell me the equation in this tangential direction? Well, let me do it. The tangential force in this case is mg, and as you can see, mg and velocity are in the same direction, so I can call it as positive. This mg will be equal to m into at. From here I can get the tangential acceleration is equal to g. So these are the equations that you can make at all of these points, starting from the lowest point to the middle point, then the highest point, then again in the return journey to the middle point. I'll give you 2 minutes now. Understand this, draw the diagram on your own, and write the equations. Once you are done, please let me know. Everyone understood these equations, how they are made? Please write these equations now on your own. So welcome back, and you are done this. Okay, now there are also 2 more points that I can make just to understand it completely. 2 more points that can be made. And those 2 points will lie somewhere in between. So let us draw the circle. First you listen and then you do it on your own. Do not do it while you are listening. Otherwise you only write and you don't understand anything. There is no point of writing if you don't understand, because I know that you are not going to read it. Or once you are going to read it, you will not understand it then. This is the time that you can understand it. So first understand, our concentration, our energy should go in understanding and not xeroxing it. In any case, you have this lecture recorded, so you can see it 50, 100 times. So don't insist, don't be so adamant on first writing and then understanding. Writing you can always do, the lecture is recorded. You can see it, pause it, see it 50, 100 times. Right now, you must understand what's done. That is more important. Now I come back to the same thing. Now I had this point A, I had this point B, C, D. All these points were done and understood. Now let me move to some point in between here, and let me call this as point E, and let me call the angle as theta. Now again I ask you the same question. What are the forces acting at point E? When it is at point E here, obviously it has a velocity. Let me call it as VE. What are the forces acting on this block at point E? No one knows it? Okay, so the forces don't change. One is mg, and the other one is tension. When you get a chance, then you speak. You don't say anything, then only I go ahead. Anyways, tension is there, Mg is there, V is here. Now again color it with my favorite color, pink. Can anyone make the equation of this block at point E? What will be the equation of this block at point E? We have to make equation in 2 or 3 direction. One is towards the center, one is tangential, and the other one is perpendicular. There is no force, so we are not making that equation. Yes, what is
E
the equation?
minus mg cos theta is equal to mve by L square.
Mg cos theta. How did mg cos theta come? How did mg cos theta come here? So you can see here the direction towards the center, one direction is like this, dung, 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 dung. This is your direction towards the center, and one direction is like this, dung, 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 dung. These are the 2 directions. Now mg is going downwards. I will have to resolve it. So how do I resolve it? You understand that this angle is theta. So if I resolve it, I will get this component mg cos theta, which goes in this direction, and I will have one component will be mg sin theta, which goes in this direction. Now you can see TE is acting in this direction and mg cos theta is acting in this direction. So what was the equation?
T minus mg cos theta is equal to mv square by L square.
E at point E minus mg cos theta is equal to mve square by L. That is absolutely correct. This is the equation that we were looking for. This is the equation that we were looking for at point E. But this is not the only equation that we can make. We can also make one equation in the tangential direction. What is that equation? If I can make in the tangential direction, what is the
Equal to
equation?
mg sin theta, sir.
As you can see, in the tangential direction, this is the tangential direction. I've already drawn it. VE is in this direction, but mg sin theta is in this direction. I always call the direction of V as positive. So mg sin theta in that sense becomes negative. So the tangential force is minus mg sin theta. And that should be equal to m into tangential acceleration. So if I cancel this, my tangential acceleration becomes my tangential acceleration becomes minus g sine theta. And very important result that now I have it in the form of g sine theta. Well done. That takes us to one more point on this side, and I will leave the other 2 points. They may not be coming. Then I have one point, let us say here on the upper half. Let me call that point as F, and just to distinguish it from the angle that we have drawn, I call the lower angle as theta, I call the upper angle as phi, so that they don't look like same. Okay, at this point it would have some velocity. Let me call it as Vf. What are the forces acting at point F?
Tension force and gravitation force, sir.
One is gravity, which goes like this, mg, and the other one is tension, Tf, which goes like this. Again, I have to make equation in this direction. You can see mg here, you can see tf here, you can see vf here. What is the equation that you can make at point F? Now again, if I look at the point F, the two directions are towards the center. This is the direction towards the center. This is the direction towards the center. Dung, 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 dung. And this is the direction towards the tangent. Pung, 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 pung. You can see mg is not going in that direction. As you can see, this angle would be phi also, alternate angles. So you can resolve mg into two components. One component of mg will be going in this direction. That will be mg cos of phi. And one component of mg would be coming in this direction. That would be mg sine of phi. Now, can you tell me what is the equation towards the center, centripetal direction?
TF plus mg cos theta is equals to mv square by L.
Tf plus mg cos of phi is equal to m vf square by L. That is correct. That is the first equation that we are looking at. But as you can see, you can also make one more equation which is towards the centripetal direction. What is the equation that you can make towards the centripetal direction? That equation would be ft will be equal to minus mg sine theta, because the direction of v is taken as positive. That will be equal to m into at, and from here you will get the tangential acceleration again as minus g sine theta. We understand this, everyone?
Sir, sin pi.
Oh, sorry, sine phi. See, I made a mistake. Sine of phi. I'll give you now 2 minutes. Note it down very, very carefully on your own. 2 minutes you have. So now we move forward and we understand some important points about this. We have this diagram at point E and F, and we have this diagram at points A, B, C, and D. Now, looking at these 2 points, looking at these 6 points, you can now write some general results, what is happening. Now, I'll write it here only. Now, if you look at this half of the circle, which half of the circle? If you look at this green half of the circle, green half of the circle, from A to C, from A to C, from A to C, this green half of the circle, from A to C, what happens to the tension? What happens to the tension from A to C? At which point is the tension highest and at which point is the tension lowest? At which point is the velocity highest and at which point is the velocity lowest? First understand this, then write it. At which point is the tension highest and which point is the tension lowest? This does not involve physics, it only involves common sense. At which point tension is highest, at which point tension is lowest? Yes.
At A, tension is highest, sir.
Great. Tension at A is highest, and tension at C is
Lowest, sir.
lowest. What about velocity? Velocity at A is
Highest, sir.
highest. Velocity at C is
Lowest, sir.
from A to C. From A to C, tension and velocity decreases. Do we understand this? Yes or no? As you go from A to C, both the tension and velocity decreases. Now let us move our attention to this section. Ding 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 ding. From top to bottom. From top to bottom, what is happening?
Tension is increasing, sir.
Okay, from okay, thank God it works. From C to A, top to bottom, tension and velocity both will decrease or increase? Both will increase. From C to A, both the tension and velocity will increase. From A to C, tension and velocity will decrease. Do we understand this, everyone? I'll give you 2 minutes to note this down. Note this down. Now, whatever we are noting are very, very important points. So, we have noted important points. Important points. Point number 1, tension at A and velocity at A is highest. Point number 2, tension at C and velocity at C is lowest. From A to C, tension and velocity decreases. We all understand this? Yes or no? Between A and B, do we remember this point B? Do we remember this point B? This legendary point B. Point B is the middle point. Do you see this middle point? Yes or no? Between this point A and B, between this point A and B, can tension become zero? Can the string become slack? Can the string become slack between point A and B? Between point A and B, tension cannot become zero. Do we understand this? Tension cannot be zero, but velocity can be zero. So if I don't give it sufficient velocity, it will start from A, go up till certain point and then come back. So tension cannot become zero, but velocity can become zero. Simple pendulum. This is what happens, right? Velocity becomes zero, it comes back. Velocity becomes zero, it comes back. Do we understand this? Yes or no? At point B, both tension and velocity can become zero. So C is the lowest point where both tension and velocity can become zero. Do we understand this? B is the lowest point where both tension and velocity can become zero. Are we able to understand this? Yes or no? Okay. Between B and C, tension becomes zero first and the string can become slack. And the bob can leave the circular path. Do we understand this? Between B and C, the tension can become zero before the velocity becoming zero. Bob can leave circular path and follow projectile motion. So it is only between B and C these things can happen. Between A and B, it can never leave that circular path. It will always keep on moving in that circular path. But between B and C, it can leave the circular path and then it will be under gravity and it will follow projectile motion. Do we understand this? You will have to remember all these things because I cannot repeat it 10 times. We don't have that much of time remaining that I can repeat them 10 times. Which is the point where the highest probability of the string breaking? At which point the string can break? Where is the highest probability? Where can the string break? At which point?
At point A, sir.
At point A, because tension is highest at point A. So that is the point where there is high probability or highest probability of string breaking. Everyone has understood all these 6 points. Now the class is over and the class is over at a very crucial junction. Now you have time to understand these 6 points. When you go back home, you draw a diagram of yourself and understand what all things are happening at those points. And remember what all things we have written here. If you can remember this, the next part will become very simple. If you don't remember this, don't understand this, you will understand nothing in the next part. So it is very, very important at this point that you understand all these 6 points. We understand this. On that note, we will wind up today's class and I'll see you in the next class tomorrow. And probably in the next class, we should be able to complete this and we can move on to the next chapter. No, we are supposed to do power as well. So power is remaining. Okay, so I will take your leave. I hope everyone has understood this. Bye bye, all of you.
Thank you, sir.
God bless you. Bye bye.